So this is the overall high-level component structure that we are going to use. So we have a Paxos layer here, and it of course supports the interface of consensus, which consists of two events: propose, through which application can propose a value, and it outputs events of the form decide, which informs application about the values that have been decided. So Paxos implementation itself is going to take advantage of best effort broadcast for disseminating various messages related to the protocol logic, and also eventual leader detector, omega, as we discussed. So best effort broadcast supports the broadcast inputs and deliver outputs, and eventual leader detector supports the outputs of the form trust. And those underneath are going to use perfect point-to-point links that we have assumed in our fail-noisy model. Okay, so this is the high-level structure. So Paxos is a leader-driven protocol, and this slide shows the overview of the code executed by the leader, by the current leader rather. So keep in mind that it does not yet include all the implementation details, all the necessary details. So this will be clarified as we progress through the lecture. So for now, this is just a high-level overview that we need in order to introduce the core part of the Paxos protocol, which is this abortable consensus here. Okay, so we have omega as one of the underlying layers, and omega will produce these trust events that will tell us which process is currently trusted as a leader. So whenever such an event happens, then we just assign a state variable leader to the identity of the current leader P. And then there is this while loop here. And this while loop is executed as long as this process itself is the current leader. Okay. And we've not yet reached decision. Okay. So we need that in order to ensure integrity, so we don't decide more than once. So as I said, what happens inside this loop is the most important part of the Paxos protocol. So this is also known as abortable consensus here. Okay. So we'll start discussing abortable consensus momentarily, but for now you can think about it as consisting of two phases. Prepare phase, in which the leader chooses a value to propose, okay, and also executes some logic that we will see what it is, in order to ensure that while it is proposing a value, no other value can be finalized at a majority of processes. Okay, so this is what's referred here as locking a majority. And then the second phase is called accept phase, in which the leader will try to convince a majority to accept the value that was chosen at the prepare phase, value V. Okay, so as the name suggests, abortable consensus may not be successful, so it can abort. So this is the reason why we have this while loop to start with. Okay, so it means that we will be invoking multiple instances of abortable consensus over and over again. So one such instance is called a ballot. Okay, so a ballot is an instance of abortable consensus. Okay, so As long as abortable consensus instance or a ballot is not successful, it was not able to reach a decision, then we proceed to the next iteration of this while loop. Otherwise, if it is successful, then the leader can decide. Okay, and also it sets the decided value to true, which will cause the loop to terminate, and then once the leader exits the loop, it will propagate the decision to everyone else using the best effort broadcast. Okay, so this is a kind of a high-level framework for the Paxos protocol. Okay, and as I said, the most interesting part is this abortable consensus, and this is what we will be spending most of our time in this lecture on.